Good morning everyone, myself Chelini Sivasai. Today my topic is Ionic Polarization. Introduction to Ionic Polarization. Ionic polarization refers to the distortion of the electron cloud around an ion in the presence of an electrical field. This phenomena is significant in understanding the behavior of ionic components in various environments. Ionic polarization plays a crucial role in the electrical properties of materials, influencing conductivity and dielectric behavior. Mechanism of ionic polarization. Ionic polarization occurs when an external electrical field distorts the charge distribution within an ion. This distortion leads to creation of temporary dipoles which can interact with nearby ions or molecules. The extent of polarization depends on the size of the ion and its charge, as larger ions with higher charges are more easily polarized. Factors influencing the ionic polarization. Several factors affect ionic polarization, including ion size, charge density, and the surrounding medium. Larger ions with diffuse electron clouds are generally more polarizable than smaller and tightly held ions. The nature of the solvent can also influence polarization. Polar solvents tend to enhance ionic polarization effects. Ionic polarization and bonding. Ionic polarization can affect the strength and character of ionic bonds in compounds. When polarization occurs, the bond may exhibit covalent characteristics, altering its properties. This can impact the melting points, solubility, and reactivity of the ion components involved. Application in dielectric materials. Ionic polarization is a key factor of the behavior of dielectric materials in electrical fields. These materials exhibits polarization that affects their ability to store and dissipate electrical energy. Understanding ionic polarization is essential for designing capacitors and other electronic components. Measurement techniques. Various techniques are employed to measure ionic polarization in materials, including dielectric spectroscopy. This method helps in identifying the relaxation process associated with ionic movements. Accurate measurement of ionic polarization is vital for developing new materials with desired electrical properties. The dependencies of real and imaginary parts of alpha I on frequency of the field as shown in the figure. In terms of normalized frequency, omega by omega 1 for one particular value of loss factor is 0.1 omega 1. Ionic polarization in biological systems. Ionic polarization plays a significant role in biological systems, influencing cellular functions. It is crucial in nerve condition and muscle contraction, where ionic movements create electric signals. The study of ionic polarization can improve our understanding of biological processes and disease mechanism. Comparison with other polarizations. Ionic polarization differs from electric and orientation polarization, which involve different mechanisms. While electronic polarization involves the displacement of electrons, ionic polarization specifically refers to ions. Understanding these differences is crucial for comprehending the overall polarization behavior in materials. Challenges in ionic polarization research. Research into ionic polarization faces challenges such as accurately modeling and complex interactions at the atomic level. The variability of ionic behavior in different environments complicates predictions of polarization effects. Advances in computational methods and experimental techniques are essential for overcoming these challenges. Future directions in ionic polarization studies. Future research may focus on the development of new materials with tailored ionic polarization properties. This could lead to advancements in energy storage, sensors, and other electronic appliances. Continued exploration of ionic polarization will enhance our understanding of materials, science, and matter physics. Thank you.